Morning everybody. This is Dr. Shivadas Nitture. Today I would like to take class on optics, and this is only a small attempt to help NEET preparing students. Actually, especially for beginner students. So it is one of my favorite topic. So I just start with optics. So as all of you know, optics is a branch of physics. Okay, which deals with the study of nature, sources, and effects of light. So in this optics, we may get so many important questions. For NEET also, it is one of the students feel tough to solve questions on optics, but usually it is very easy if we know the concepts of and ray diagrams and few methods and few sign conventions. Let us try to take first part of it. First, I would like to tell you about the object and image in the case of ray optics. As I written here, object, right? Object means anything from which the ray is coming. So if you want to see any object, say this is an object, right? So if rays comes from this object, if this object is a luminous object, it may be self-luminous or it may be non-luminous. If rays are coming from it, then you can see this object passing through this eye. You can see these rays converges to some point, and at that point you can see the image of the object, right? So throughout the optics, there is one object and one image. But question arises, how these object and images are? Actually, there are two types. This object and this is image. I will just try to explain you how you can identify which type of object it is and which type of image it is. Because as going for NEET, we don't need theory too much, we want only tricks. Because tricks works in the examination. For each question you will get only 1 minute. Okay. So in objects there are two types. One is real object, another one is virtual object. Similarly in case of image also, you can see real image and virtual, right? So this R stands for real. R stands for real and V stands for virtual. Real means it is at the exact position where you are seeing it or from where it is coming. Virtual means it appears to be there but actually it is not there, it is somewhere at some other place, but when you see it seems to be there. Why? Because rectilinear propagation of light. In optics, first we are dealing with ray optics. Here this rectilinear propagation of light is very important. So what this rectilinear propagation of light tells? According to rectilinear propagation of light, according to this rectilinear propagation of light, light always travels along a straight line in a given homogeneous medium. If the medium changes, then only it changes in direction. For example, this is air and this is glass. As soon as it is in air, it is traveling along a straight line. When it enters from air to glass, it changes its direction. So in a homogeneous means same medium, it is traveling along a straight line. Okay. That's why in some cases they may come and they bend here, but the person standing here, what he sees, the rays is coming along this direction. So this is the object. You can see its image somewhere here. So this ray acts as an object for this person. So these are the tricks and techniques which will come in our ray optics. So that we should know. We will tell you how to identify the real and virtual images. Very simple trick. In rays of light, you can take a beam of light. A group of ray of light is called as beam of light, right? In the case of beam of light, there are two types: convergent beam and divergent beam. So convergent means first you take divergent. Divergent means if this is a point source and the rays are going away from this point. So this is called divergent. Convergent means if all the rays meet at a point. So that this point is called as convergent. So let us come here. Real object. When object is called here, assume. So please remember, if from any point rays are diverging, very simple. Rays are diverging, then this object is real. If rays appears to be converging at some point, when Okay, then this object is called as virtual object. Object means always you think about incident rays. If there is a lens, then incident rays are coming from the object. If incident rays are divergent, object is real. If incident rays are convergent, object is virtual. Similarly, in the case of image, if reflected or refracted rays are convergent, look, I am putting arrow marks. If there is arrow mark, then that is ray. If not arrow mark, then that is not a ray. This is conversion. All are conversion here. After reflection or refraction, I am talking, not incident rays. So this is a real image. If the ray appears to be diverging, like this, then this image is called virtual image. These points we should remember. Okay. Now next move forward. Next one. I will tell you. In the next case, as we see in our textbooks for NEET exam, first they talk about the plane mirror and image formation in the case of plane mirror, and what is the nature of the image, and some other reference like deviation produced by a plane mirror, how images forms, like that we are going to discuss. First, let us talk about the image formation in the case of plane mirror. So here you can see. So in this diagram, you can clearly see there is a plane mirror. Some yellow is there in the diagram. Here some object is placed. I will write here. Why I have taken this diagram is, while drawing I may not draw it correctly since it is my first video. I take time to draw neat diagrams, but due to the first attempt we have to do anyhow, because only practice can happen after so many attempts. Instead of sitting and trying, it is better to try in a live performance, right? So this is the plane mirror. Say it is M. So let us place, say take this as a ground. Let us take one object here. Okay. As in the diagram you can see. Take here. Take this as a object. Object means from object incident rays are coming like this. Say this is tip. Straight parallel beam, parallel line falls on the mirror. So this is parallel to this axis means it is normal incidence. After incident here it will come back. We forget, for those students who don't know reflection, please remember this is a plane surface. If any surface falls like this is called oblique incidence. And incident ray is falling here. For reference, you will draw a normal line like this. It's a normal line. Why you are drawing this? To measure angle. So this ray incident at some angle, say this is theta. Okay. So this is called oblique incidence. ये ऐसा गिर के कैसे जाएगा? It will go like this. Obeying the following laws. What are the laws? This angle will also be theta. So this is the reflection. If these two angles, angle of incidence, angle of reflection, both are equal after following an incident of the plane mirror. Okay, this is called reflection. And all these, this is incident ray, this is reflected ray, and this is normal drawn at the point of incidence. All lie in the same plane. So here also, this is normal. Look, if ray of light incident along this direction, and there is no way, it will go like this only. Angle is 0, then angle of reflection is also 0. As in the case, if incidence like this, and this is going like. One more ray, it will fall on this point. After reflection, what we will do? This is the normal line. This will make the angle theta. So if there is oblique incidence, it will go like this, making some equal angle theta like this. Understood? So what happens? Incident rays are these. These are the incident rays, right? Coming from this object. Check whether object is real or virtual. These are divergent. So this object is real object. Right? Now take image. Image means reflected ray. What are reflected rays? This ray is, one ray is going along this direction, another ray is going along this direction. So what observer sees, peculiar relation of light, he sees this may be the direction. If some observer is standing here, what he gets the impression? This ray along this direction and this ray is coming from this direction. When they meet at this point, You can see the clip A image here. Similarly, if you draw for whole body, the image will be like this. So this is the image formation that is a plane mirror. Check which type of image is this. This image is, look, what are the rays? Reflected rays. One ray is going like this, another ray is going like this. It means divergent. Divergent means virtual image. That's what I have done here. Image obtained is virtual. Image is laterally inverted. Laterally inverted means if you stand like this is your left hand, this is your right hand. In your image, what you see? This is your right hand and this is your left hand. Laterally inverted, like this. Image is direct. Direct means straight. If head is upside, here also head is upside. If it is like this and this is like this, then they are called inverted. But both the heads are up only, so it is direct. Size of the image is same as that of object. This height and this height are equal. Distances are also equal. If this is object distance x, then this is the image distance. Like this here is given. From here to here, this is object distance. So this is image distance. Both are equal. These points you have to remember. Understood. Next, let us go for the next slide. Here, what I have done, angle of deviation produced in the case of plane mirror. Look about this way, right? Angle of deviation produced in the case of plane mirror, right? This is a plane mirror, and this is incident ray. This is a reflected ray. This angle is theta. This angle is theta. What is deviation means? This is incident direction, right? This is the incident direction. This is the reflected direction. So this is the angle of deviation. This total angle is 180, and this angle is how much? This is 2 theta, and the remaining is 180 minus 2 theta. If somebody asks you to calculate angle of deviation in the case of plane mirror, then you should directly write 180 minus 2 theta. If theta is say 30 degree, then angle of deviation is 120 degree. We come to this diagram. Here I have done. Here are 2 plane mirrors like this. One plane mirror and another plane mirror. These are the 2 plane mirrors like this. They incline at angle theta, and in this case we have to find the angle of deviation. Look, here one ray is incident like this. In this diagram you can see, and after reflection, this is the normal one at the point of incidence. This angle after reflection, it will have to draw a very good diagram. Here, reflection, it will go like this, and again it falls here. Sorry, normal means normal. Like this is the angle, and after reflection it will become this. Incident, this is reflected. So this is incident direction, this is reflection. Angle of deviation, what you have to do? From this ray to this ray, you have to measure this angle. Look here, if this angle is x, this angle is also x because of reflection. And look at this diagram. This is the incident direction. Okay. What is the angle of deviation here? This is the angle of deviation, so delta 1. Whatever delta 1, and delta 1 has how much? 180 minus 2x. Because these 2 angles are x, x to x, this total is 180, and it minus 2. Similarly here, if I take this as y, okay, after reflection it is going like this. This is the incident direction. And it is going like this. What is the angle of deviation? This is the angle of delta 2. And how do we have delta 2? Delta 2 is 180 minus y, because y, this total is 180. Remember, if this is the normal line, understood? And this is 90 degree. This is y. And how much this is? 90 minus y. How much this is? 90 minus x. In triangle, theta plus 90 minus x plus 90 minus y is equal to 180. So this 90, this 90, this 90 cancels. Theta is equal to how much? X plus y. So total deviation is delta is equal to delta 1 plus delta 2. What is delta 1? 180 minus 2x. What is delta 2? 180 minus y. So what I do? I do 180 minus 360. I take minus 2 as common. This is x plus y. So this is 360 minus 2. X plus y is theta. So 360 minus 2 theta. So here, this is for understanding purpose. In your need, what we do, if there is 2 angles like this, and if this angle is 60 degree, If the term sign goes like this, what is deviation means? What you do? 360 minus 2 into 60. That is 360 minus 120. That is 60 minus 20 is 40. We use this 240 degrees angle of deviation. And we have to do the angle of deviation. Friends, if you have any doubts, you can ask me. Person. Understood? So go for the next slide. This is very important one. Come here. Actually, the name of the topic is number of images formed by inclined plane mirror. Inclined plane. If two plane mirrors are inclined by some angle, like this is one plane mirror, this is another plane mirror. If there is some angle theta is given between them, if some object is placed between them, the question they ask, how many number of images are formed? For this, what you have to do, you have to take this angle theta. First, you have to take 360 degree and divide 360 by theta. Theta is angle between two mirrors. So we will get one integer, which may be odd or even. Odd means 1, 3, 5, like this. This is odd, right? Even means 2, 4, 6, like this. This is even. So if you get even number, it is written here. If you get even number, understood? It may be symmetric or anti-symmetric. In both cases, the answer is same. Symmetric, I will tell you. So if this division is even number, for example, if it is 90 degree, 90 means 360 by 90. What is 360 by 90? That is 0, 0 cancels, 9, this is 4. So 90, understood? This is the even number. Then how many number of images are formed? Remember the formula. Number of images formed 360 by theta minus 1. If angle between the mirror is 90 degree, integer is 4, then the number of images are 4 minus 1, that is 3. Remember that directly. Symmetric or anti-symmetric. It means this object may be placed anywhere, equal bisector or anywhere. In this diagram it is given. If this is the point of the object, and if this line which joins this origin, and if this line divides this total angle, okay, by 20 degree and 20 degree equally, 20 degree and 20 degree and equally, this is called symmetrically placed. Students, please remember. If this line, which is a bisector of the angle, which is the line joins the object from the point of intersection of the mirrors. If this line divides this total angle equally, this is called symmetrically. Look here, this is 40 degree, but this angle is 10, means this angle is 30. So this line, which is coming from the object to the point of intersection, dividing angle unequally. This is called a symmetry division. In the case where if 360 divided by theta is odd number, then in this case this question arises. For symmetric, the number of images formed is as usual 360 by theta minus 1. If for asymmetric, then it is directly 360 by theta. This is the question. Understood? If say 72 degrees is the angle between the two plane mirrors, then what is capital N? It is 360 divided by 72. 72. Okay, then you divide this. How much it will be? You can check. 72. Okay, how much it will? 36 1 and 36 2 is 72. 2 1 this is 5. So this is number of this integer is 5. This is odd, right? In this case, odd but equally dividing. In this case, number of images formed are 5 minus 1, that is 4. But in this case, if it is asymmetrically placed, then number of images are 5, not 4. This is very important. Please follow these tricks, very important tricks. Once we know these tricks, they will be very easy to comprehend. This is one fantastic last. This is the last topic which I am covering in this video. And in this case, what I am doing, what is that? What is the height of the mirror required? The question is like this: what is the height of the mirror required? Height of mirror required to see complete image of the object standing in front of the mirror. Complete image of object standing in front of the mirror. Then we have to check. We will draw a separate diagram here. So this is the mirror. Okay. So the height of the mirror is that we have to calculate, right? Say this is a person standing in front of the mirror like this. So this is head of the person, and this is eye of the person at this point. So this is eye of the person, and this is the bottom top of the person. Total height of the person is say h. I have to check what is the height of the mirror. This is small h. To see his complete image in this mirror, he should see his head and toe in the mirror. Then only he can see. First, the ray coming from the head hitting at the top should reflect. If it reflects from this point, okay, this reflects from this point, this angle theta. Okay, then the other angle is also divided. This is high, right? I should have taken this to be this as a point here. So it will come here. Take this okay. Can take some. So then a ray coming from the top should fall at the last point of the mirror, and again it will fall along here like this. And this ray reflection, it should reach here. This is I. It means both the rays should reach I. Okay. So look at this. This is dividing the mirror into two half. Let this height be x. This distance be y. Look, if this is x means this is x. If this is x means this is also x, because these two triangles are having same angle. Then these side and this side are equal. And if this is y, then this is also y, right? So look here. What is the total height now? Here it is 1x, 1x, 1y, 1y. It means 2 times of x plus y. And what is here? Mirror x and y. This is x plus. Check here. This is 1x, this is 1y. This is the height of the mirror. For man, this is x, 2, and this is y1. So it means the height of the mirror is half of the height of the person standing in front of the mirror. Like this you have to solve the problems. Same case sometimes he is asking errorless. This is the mirror, and this is wall behind the person. Person is standing here. To see this wall completely in this mirror, the height of the wall is h, then height of the mirror should be at least h by 3. Here height of the object and height of the mirror should be actually h by 3. So like that you have to solve. Friends, this is, thank you very much. I will continue such works in future. Thank you very much.